Hello and welcome back to Chem Clips by Mr. B. In today's video, we're going to be focusing on tackling a multiple choice question on percentage yield. Before we start though, I think it's important that we remind ourselves what is meant by percentage yield and why it's important. So percentage yield is simply a tool used to determine how wasteful your reaction was, or how successful it was, I suppose. Why is this important? Well, in the real world, there's often loads of waste being produced when a product is being synthesized either in the lab or within industry. And it's important for an organic chemist to work out how wasteful the reaction was. There's often side reactions taking place, so whatever product you're manufacturing, it's the reaction that you're carrying out will never be exactly as the equation suggests. There will be side reactions taking place ultimately. So how do we calculate it? Well, it's calculated simply using the following formula, and it's simply the amount of product that you've made over the amount of product that you should have made. So I'm going to write this down as, and notice I'm using the very ambiguous term amount of product. So amount of product, and I'll explain that in a moment. Amount of product produced over the theoretical amount of product multiplied by 100. So the reason I've used this very ambiguous term of amount of product is simply because if you're given masses, if you're working out a reaction using solids, then you're going to be given masses. If you've been given more, which is if you're going to be given a reaction which deals with organic liquids, then you're most likely going to be given volumes. My suggestion is scrap all of that and use and work out the moles. So you're going to use the equation amount of moles of product, or moles of product, divided by the theoretical moles of product multiplied by 100. It's going to save you a whole load of bother. So let's apply this to this question and see how we get along. So I've been told that I've got 268 grams of ethanol with an MR of 46.0, and I've got 1.44 kilograms of glucose with an MR of 180. So I've been given masses. What can I do with these masses? I can work out the moles. What equation am I going to use to work out the moles? N over MR. But we need to be cautious here because we've been given the mass of glucose in kilograms and we need to convert that to grams. So let's work out the moles of glucose and work out the moles of ethanol. So N of ethanol is simply going to be 268 over the MR, which has been kindly given to us as 46.0, and we're going to work out the moles of glucose, C6H12O6, and that's simply 1140 divided by 180. So if we do this and we work out the moles of each one, we've got 268 divided by 46. Oh, that's 46. We get an answer of 5.82. So not, that's 5.83. Do 36 figs. Okay, and if we do the same for the, sorry, that was the moles of ethanol, not glucose. The moles of glucose will be 1440 divided by 180, and that gives us 8 mole. Okay, so we know that we've produced 5.83 moles of ethanol. That's the amount of our product that we've made. But we've not been told what the theoretical moles of ethanol should be. And this is where the glucose value comes in, the 8 moles of glucose. If we look at the equation, we've got, for every 1 mole of glucose, we are making 2 moles of ethanol. So we've got a 1:2 ratio between glucose to ethanol. Now we've just worked out that we've got 8 moles of glucose to start off with. Now, if we've got 1:2 ratio, then that means theoretically we should have made a total of 16 moles of ethanol. So I've now got my theoretical moles or theoretical amount, and that's 16 moles. I've worked out what my actual moles of ethanol is, and we're simply gonna pop into the equation and see what we work out, see what we get for the answer. So we've got, what is that? 5.83 divided by 16 multiplied by 100, and that gives us a total value of 36.4, which means that the correct answer is B. So our actual sum was simply 5.83 divided by 16 multiplied by 100. It's that simple. Now, there is a bit of a point I'd like to mention over here, and that is, in multiple choice questions, it's always preferable if you could eliminate certain options. Generally speaking, percentage you would be extremely lucky to find that you carried out a reaction with greater than 50% yield. If you find that you've carried out a reaction in the lab and you've got a yield which is 50% or greater, pat yourself on the back, because that's an excellent result. So immediately, if we know that having a value of 50% or more is generally unseen, then we can immediately discount the fact that D isn't going to be the right one, because that's 72%. And C, it's kind of on the borderline, but we can kind of eliminate that also, leaving us two choices, which, if we actually work out the maths, which we have done, works out as giving us the answers B. Okay, hope that was useful. I'll see you until next time. Bye.